Common emitter transistor characteristics. The three important characteristics of a transistor in any mode are: first one, input characteristics; second, output characteristics; and third, transfer characteristics. The circuit to study the characteristic curves of NPN transistor in common emitter mode is shown in figure. First one, input characteristics. Input characteristic curve is drawn between the base current IB and voltage between base and emitter VBE. When the voltage between collector and emitter VCE is kept constant at a particular value, VBE is increased in suitable equal steps and corresponding base current is noted. The procedure is repeated for different values of VCE. IB values are plotted against VBE for constant VCE. The input characteristics thus obtained is shown in figure. The input impedance of the transistor is defined as the ratio of a small change in base emitter voltage to the corresponding change in the base current at a given VCE. Hence, input impedance Ri is equals to delta VBE upon delta IB when VCE is constant. The input impedance of the transistor in CE mode is very high. Output characteristics. Output characteristic curve are drawn between IC and VCE when IB is kept constant at particular value. The base current IB is kept at constant value by adjusting the base emitter voltage VBE. VCE is increased in suitable equal steps and corresponding collector current is noted. The procedure is repeated for different values of IB. Now, IC versus VCE curves are drawn for different values of IB. The output characteristics thus obtained are represented in figure. The three regions of characteristics can be discussed as follows. First one, saturation region. The initial part of the curve, ohmic region OA, is called saturation region. That is, the region in between the origin and knee point. Knee point is the point where IC is obtained to become a constant. Second part, cutoff region. There is very small collector current in the transistor even when the base current is 0. IB is equals to 0. In the output characteristics, the region below the curve for IB is equals to 0 is called cutoff region. Below the cutoff region, the transistor does not function. Third part, active region. The central region of the curve is called active region. In the active region, the curves are uniform. In this region, EB junction is forward biased and CB junction is reverse biased. The output impedance R0 is defined as the ratio of variation in the collector emitter voltage to the corresponding variation in the collector current at a constant base current. In the active region of the transistor characteristic curves. Hence, output impedance R0 is equals to delta VCE upon delta IC when IB is constant. The output impedance of a transistor in CE mode is low. Third one, transfer characteristics. The transfer characteristic curve is drawn between IC and IB when VCE is kept constant at a particular value. The base current IB is increased in suitable steps and the collector current IC is noted down for each value of IB. The transfer characteristic curve is shown in figure. The current gain is defined as the ratio of a small change in the collector current to the corresponding change in the base current at a constant VCE. Hence, current gain beta is equals to delta IC upon delta IB when VCE is constant. The common emitter configuration has high input impedance, low output impedance, and higher current gain when compared with common base configuration.